Hello, everyone, and welcome to another edition of Nutanix Weekly. This is your host, Phil Sellers, joined with a great panel of folks here. Another XenTegra podcast with, what do we call it? With context. Um, Joined today with Harvey Green, CEO of XenTegra Gov. Harvey, how you doing?
I am pretty good. How are you?
Doing pretty well. Also joined with Jirah Cox, the man, the myth, the legend. Jirah, how are you?
Uh, hey, Phil, I'm doing good. I don't feel too legendary, but I'm here.
Well, I guess it's better than being infamous, right?
And it beats being mythical. So,
And we are joined by the mythical Ben Rogers. Then, how are you, man?
Good. For those that are seeing this, I am safe. I am in a good location. So don't be worried that I look like I'm in a dungeon. So we're all good.
We were checking on him just a little bit ago. So,
Yeah, trying to look for clues, make sure that Ben's not been kidnapped or otherwise detained against
Man,
his will.
wouldn't it be so impressive to be so important that somebody wanted to kidnap me? Yeah, I'm honored, dude. Thank you.
Or like my kid told me the other day, you're not a kid, you can't be kidnapped. So
Mine would
wow.
go in 24 hours. They would want to give you back. They'd be paying us to take you back.
Well, guys, thanks so much for joining us. So we're here to talk Nutanix. It's another week. Things haven't stopped. Things are continuing to move forward. Nutanix is continuing to make progress and release new things, and yeah, that's one of the things we've got today. So we've got a new blog post out, fresh off the presses. Just-in-time cloud storage for Nutanix Cloud Clusters, written by Dewayne Lessner. Shout out to Dewayne. Thank you for giving us something to discuss. We appreciate all of the contributors and stuff from inside Nutanix that are constantly investing in the community and giving us good information, keeping us apprised what's going on. So shout out to Dewayne today.
So, Philip, can I interrupt you for something? Because I think I'm going to make the guest of this podcast, the people that listen to this, happy. I'm going to admit that this is a subject I do not know a lot about today. So I am coming here as a Nutanix employee, but as a Nutanix employee, I'm looking at a service that I really don't know a lot about. So at this point, I kind of feel like I'm listening to the podcast to learn. So for your listeners out there, we don't always come prepared and we don't always know all the subjects. And this is definitely one that I am not up to speed on. So I'm very much looking forward to the podcast and learning about EBS storage in NC2 Cloud.
Yeah, this is an exciting one, right? I mean, that's the thing, right? We're talking about things that are brand new. There's not a lot of experts. I mean, especially outside of Nutanix. This is brand new. This is hot off the presses. It's been in the wild, at least this blog post has, for a whole 5 days. So, but none of this stuff magically happens, right? I mean, this is part of a roadmap. This is part of a long-term plan, that folks in Nutanix have been executing on, and so that's the cool part is now we're getting to benefit from that long-term roadmap. I mean, as we talk about cloud clusters and things like that, let's take a quick minute before we jump into the blog post and let's level set. What is a Nutanix Cloud Cluster, Harvey?
That is I won't call it the newest because it's not that new, but that is the extension of Nutanix and the architecture and the platform to run within the public cloud, specifically Amazon AWS and Microsoft Azure.
Yeah. What's different about Nutanix Cloud Clusters than any other Nutanix installation, Jirah?
actually, shockingly little, right? So they run the exact same Nutanix code, right, for the hypervisor, the storage fabric, the management layers, the automation, as any cluster you'd run on-prem as well, right? So really, you're just rather than owning hardware in your data center, you're renting hardware in somebody else's.
Yeah. So, I mean, that's a great level set and place to start is, this is the same Nutanix we know and love from on-prem. It's just now sitting in someone else's data center, in this case, AWS and Azure. So, back to Ben's point, start there. Really, what are we talking about? Where are we talking about it? For the purposes of this blog post, we're going to be spending a lot of time talking about AWS because that's where the new innovation's happening from this topic. So, Jirah, why don't you kick us off and tell us a little bit of what's the news here? What's the news in NC2?
Yeah, or maybe even why is this so great to have, right? And what's the circumstances where customers would want to use this, right? So one more compare and contrast, right, with running clusters on-prem. When you own the hardware in your data center, right, you can assign a human to go touch that hardware, change it any way you want to, right? Specifically, like, maybe increase the size of the storage there, right? Pop in some new SSDs or whatever to grow a cluster and expand that storage pool resource. With, of course, a rented node in AWS at the bare metal layer, there you have a few options of flavors of bare metal node type, but it is still off of a menu, right? You're going to get this node or that node. It's going to have certain dimensions, certain parameters, storage being one of them. And there's really kind of no size of check you can write, no human you can call to say, hey, can you go add 2 more SSDs to these nodes in that data center for me, please and thank you, right? Like, that's going to go nowhere. So the hardware configuration is kind of locked. So then how do the scenario, right, for our customers is, how do we help our customers enjoy the same kind of flexibility, right, to create clusters that are tailored to their needs, CPU, memory, storage, when they move to, say, from an on-prem data center or a colo into public cloud. Yeah. And so that's the use case for this, right? That where we haven't had that before. If a customer wanted to, say, replicate workloads to NC2, because that's pretty fashionable these days, right? Using owned resources on-prem in a primary data center. But a lot of customers look at it and say, hey, I don't want to do a DR data center anymore. Move my DR to the cloud, right? I want to rent that instead, or use that as my first kind of cloud workload as my DR for my on-prem VMs. So if we come back to them with a customer to the customer and say, here's a design for you, you need 3 or 4 nodes worth of hardware to run your VMs, but you might need 6 nodes or 8 nodes worth of storage based on this cookie cutter node size to store your VM data. Well, now the customer's paying quite a bit of money for those 4, 5, 6, 7, 8 nodes that are just there for data storage and aren't there for the compute side need. Or they're not needed for application. They're only needed maybe during an activation of the DR environment, right? So then paying for them all the time is a bit prohibitive. So that's kind of the scenario of like helping customers out that this feature now is kind of justified by and kind of born into, right? That's the context.
Yeah, and you pointed out something I think that's really important. This often comes up when we're talking to customers about DR scenarios. So if we're talking about rehosting an entire workload into NC2, those generally make sense. You need the number of nodes you need based on compute or based on storage. Those use cases make a lot of sense because you're going to need and consume all of that up front. But with DR, you just need a place to land that data. You're not necessarily always going to need the compute to go with it. And so there's this out of balance thing that happens between your node because generally they don't have enough storage for that particular use case. We're talking about AWS today, but I know Harvey and I have worked on a couple of deals where we had an Azure customer, and there's even more restrictions on the Azure NC2 because there's 2 node types as opposed to, I think we're up to 6 or 8 in AWS now. Is it 6?
Something like that for sure, yeah.
We would have to actually go check.
That is directionally accurate.
Yeah. We'd have to check.
I can look that up for you.
But there's at least more variety to choose from. But again, in DR use cases, it doesn't quite fit. So I think that's a great way to set up the discussion. So I'm not going to make us wait any longer. What are we announcing, Jirah?
So with this new feature here, right, with the ability to connect EBS here, which is like the Elastic Block Storage, right, additional block storage that exists outside the customer's nodes, but still within the parameters of AWS, you can now attach block storage to the Nutanix nodes to create additional storage, right, to present more additional storage. Basically, very much akin to the scenario I talked about before, where you would just pop in additional SSDs into nodes that you own, nodes you control. Same kind of outcome now available now for cloud clusters as well. This gives you a lot more flexibility as you design this to say, I don't need a lot of compute for perhaps for DR, right? All I'm only going to run is like my Nutanix CVMs to host cloud storage and be my replication target. And I just want all the storage I can talk to then to replicate as my actual data tier there.
Yeah. For those of
I
you
need
watching,
confetti and special effects. Like,
And there was much rejoicing.
yeah, I mean, we need a sound machine for this podcast.
We'll put that in.
I think I'm
edit, right?
scared of where that would go.
But I'm sure the podcast host can put that in the edit, right? There is an edit phase, right?
Yeah, there's strictly no editing on this one, right?
Hey man,
No, but I mean,
we got one take. Just
Yeah. one
That's
take.
it.
That's why you get here. No, I mean,
Come on.
it's fantastic. I mean, now you've got that extensibility, right? So particularly for the DR use case, you add the extra block storage you need. Takes some planning, some sizing on the front end, but now you can accommodate that in what we would call a pilot-like cluster. Is that a term that's well known, I guess? I mean, pilot-light, when we start talking about DR, I mean, do you guys know what that refers to?
Yeah,
it's just
actually
a framework.
I've actually heard more people referring to it that way outside of conversations that I've had before. And I was like, oh, I'm not the only one that says this. All right, cool.
Yeah, and that's kind of the point of reference, right? Like, it's sort of like a pilot light on your stove or on your gas logs or something. It's there running and waiting for you to turn the switch on and need to turn it on. And that way you're ready to go when you turn on the switch. And so it's a minimal cluster in terms of Nutanix, but that makes a minimal cluster now much more powerful, much more valuable to the customer. So this is cool stuff. I mean, where do you see additional capability kind of coming in from your perspective, Harvey?
I mean, ultimately for me, this is protection against all the stuff you don't know is coming. Because you go and design this and you can design it as accurately as you want to all day, but there will be things that you did not account for that somehow have to get taken care of. And this is your get out of jail free card.
And Ben, I'll throw it to you. I mean, as you're working with customers, I know as I'm working with customers, future proofing is a big part of what we do when we do sizing and create, configs for them. Being able to slide it. I mean, like Jirah said, I mean, being able to effectively slide in more capacity. I mean, how huge is that for cloud?
Well, it's going to be huge for us, particularly. I'm speaking now on the sales end. We've done a lot of deals where the nodes, the clusters got heavy compute wise because we were trying to facilitate a storage problem. And so now with our ability to add storage to these clusters, that's going to be great because now we don't have to inflate the compute cost anymore. We can really look at what are the services that the workloads needs and properly design them. So from an IT configuration perspective, this is going to be awesome. I do have a few questions about this. I see in the drawing here that we're adding this storage directly to the nodes. So essentially, to Jirah's comment, this is like popping in some extra SSD or NVMe to these nodes. Jirah, do we have to add equivalent storage to each node, or can you explode one node, or kind of give us an idea of how does this peanut butter spread across the cluster? Is it done. Each node's going to get an additional EBS slice, or we could have one EBS on one node and the other nodes. I'm kind of confused there of how we would architect this.
Yeah, so details, of course, do matter, right? So the article calls out at this point, we're going to look at adding the storage to the nodes in the cluster with uniformity, right? So we'll add that to every node in the cluster. Also, just one more point, which is not a huge consideration, but it's a minor consideration, is that this is a cluster creation time decision. Now, that's also pretty easy to deal with, right? Because with this ability to have this hardware on demand, moving from cluster size to cluster size and moving those workloads within a cloud AZ actually is way easier, right? Because there's not that whole on-prem data center experience of like, I order a truckload of new nodes to live next to my old nodes. I have to do something with the old nodes. No, we're just going to, for a few hours, rent 2 different clusters, move workloads over, and move from profile A to profile B. So it's not like quote like a hot add. Exactly, the outcome is the same as adding those SSDs to a node, but the workflow to get there is a little bit different than just popping them in, because of course it is different.
And that's a shout out to native data services, right? You can just use built-in replication and all of the great things we know from a DR perspective to move from one cluster to another.
Totally, it's a very it's a very much cloud principles, fail forward, declarative infrastructure version of the same outcome, right? Of get more storage versus a sort of day 2 pets operation of like find a way to do it, while the airplane's in the sky.
Yeah, sort of like versus refueling in the sky. I like that. So the EBS is attached. It looks like in different mount points. I mean, I know the listeners can't see it. The blog post has got a great visual here that Ben mentioned that kind of shows the EC2 bare metal hosts, and you've got your controllers, your AHV, your user VMs, and then the storage controller with different those mount points, one for AHV, one for the CVM, local storage, and remote storage. Is that effectively how it happens under the covers?
Yeah, the neat thing is what's really cool here, right, is that EBS storage, when it's presented to the Nitro card in AWS, basically just looks like a local block device, right? So we really haven't had to teach, no disrespect to engineering and all the work put into this feature and testing it and qualifying it for customers, but it's not like we had to go teach the CVM to go speak a whole new language here, right? It's basically go find other local block storage within the node and make that part of a usable cluster, which we've been doing since literally day 1 of the company, right? So, and it even calls out here in kind of the way the Stargate, which is our main IO handler, handles the storage, right, is very similar to like a node that would have physically present local NVMe and physically present local SSD. Of course, those are both fast, but one is a little bit faster. So that's where writes are going to land, and then destage down to the SSD tier. Similar here, if there's local NVMe in the box and then EBS attached to it, all that NVMe locally is, of course, just a tad bit faster, a lot more local. We'll use that first and then spill down over to the that EBS storage.
So, Jirah, what that's telling me is our data locality and all the goodness that we have built inside the cluster still remains. The cluster's smart enough to figure out if the load needs to be on local storage or on this EBS storage.
Right, of course. I mean, that was our first real data handling, data governance trick, right? Was understanding what is the hottest part of data and keeping that as localized and as close to the workload as possible, right? Remember how we started the company, right? Was with nodes that might have like, say, 100 gig SSD and like 2 terabyte spinning disks. Not a whole lot of very hot storage there, right? So we had to be pretty darn sure what was the hot tier storage and what needed to go there. And by the way, that SSD would cost you like 10 grand for 100 gig back in the day. That was the long pole in the tent of the hardware bomb. So even though, of course, as data center hardware has evolved over time, right, and cost per gig has come down dramatically, our data placement engine, right, of profiling storage and knowing what needs to be placed the closest to the workload, of course, still has value and still is in place.
So someone coming into the AWS conversation, can you tell us a little bit more about that Nitro card? What is that actually? Because like many things in the AWS arsenal, it has branded names, and that may not actually explain what
Yeah.
it's doing here.
Yeah. So great question. I'm almost as much of a layman as probably everybody else on the call, but my view of the world, right, is that the Nitro card, it is the DPU, right, the super fancy NIC within the node, right, that allows AWS to do all of the awesome AWS stuff at the data center level for the hardware, right? So that's where your networking gets handled. In this case, also storage as well. So things that they can do like that, present external storage as a local device. Of course, that's because the Nitro card itself is custom silicon. You only get Nitro NICs within AWS, right? It's not hardware you can run in your own data center, but it's part of what helps them run their cloud at scale as a hyperscaler.
Yeah. So we can think of it as sort of like a cross between a out-of-band management interface and a physical PCI device, because it sits on the PCI.
Sure.
On the PCI bus.
Out-of-band, in-band, overlay, underlay, plus what? If you squint, I guess it could play the role of an external storage HBA plus like SAS expander. Like it's sort of all of that rolled into one, because ultimately all those things are just software definable functions, right? And of course, everyone at AWS now is rolling their eyes at our terrible analogies for their, I'm sure, awesome silicon that they're very proud of.
Because it's got to be fast. Everybody knows you hit the Nitro button when you want something to be fast.
That's it.
Yeah.
It's a
next week. Hear other technology badly described.
But it's the smarts. I mean, I think to sum up what you just said, it's the smarts that makes this really a composable, just to throw out another buzzword in the infrastructure industry, but a composable type of hardware. So again, back to what you're saying about software defined, you can take this and turn it into something more through the software. And that's what the power of the Nutanix platform on this bare metal is actually giving to us, is that composability to make this into a much more useful form than its native components. We talk a little bit more in this blog about adding and tiering that we've already covered. Let's talk a little bit about the on-demand growing. From a DR use case, we've got that 3-node pilot-like cluster. What happens when we want to do more or when we need to expand? Like, what does that look like?
Yeah, a really cool outcome that this feature now gives us is that before we had really one way to grow a cluster, and that was to literally grow the cluster, pop in more nodes, which we did add support for mixing node types within a cluster in the past. That was really great to have. So you could have larger nodes to start with, and then maybe add more compute-heavy nodes over time. Now we have 2 ways to grow a cluster, right? That one stays, the first one stays on the truck of you can always add more nodes to grow a cluster. But now if you have a cluster that has this EBS feature attached to it, you can also scale up the EBS storage itself. So if you just needed more storage, then whole separate lever, candidly, whole separate price point for scaling there to say just add more storage to a cluster without needing to reach for the add more compute, add more nodes solution as well. So great ways to solve more problems. And what's cool now is the article calls out that you can actually attach, really a dramatic amount of storage here, right? So we still use our kind of rule of thumb here of we want to see about 20% of the cluster storage stay within the nodes, right? We don't want to run with 100% fully EBS storage, but you can have up to 4x as much attached to it, right? So you can have 20% locally in the box, 80% off on EBS. So that's really a very large amount of storage, and B, very cost effective in terms of that tier that you're going to use there for that storage as well.
So, Jirah, I want to make sure I understand here. We have to make a decision to use EBS storage at the time of cluster creation. So I know I'm building a DR cluster. I know I'm going to want to use some EBS. I want to go ahead and establish that at the time of build. But you're also telling me that when I have to declare a disaster, that I can grow these EBS storage LUNs dynamically. They can be increased on the fly as I'm bringing up my disaster recovery scenario.
Yeah, so you definitely can scale up the EBS storage at a later time. That's called out here in the article. I would think what's probably more realistic there, Ben, is you could add more nodes for a DR disaster, right? When you need more compute, but of course you can scale up the EBS at any time, right? But that would be more for like a data growth handling, and then light up more nodes if I need more compute. Then my pilot light cluster might be able to handle from the CPU memory side of things.
Awesome. I was worried you were going to say that we would have to do another, new cluster with new sizes and migrate over there. It's good to see that we can expand it on the fly, though.
Yeah. That's just for the get to no EBS attached to have EBS attached shift. And of course, if you're listening to me, like if you're thinking about this, I would say this is probably going to become a pretty instant best practice to say attach a minimal amount of EBS to your cluster,
Yes.
whether you think you're going to need it or not, because over time you're probably going to change your mind and decide you do need it. So start with that attached to begin with.
That advice is definitely Harvey approved.
So kid tested, Harvey approved. Yeah, no, I mean, I think that's great advice. I mean, anyone looking at NC2, putting in a minimal amount of EBS just buys you flexibility. So, you do have the ability to grow it. That's huge. And honestly, the first time I read through this, I missed that point. So that's another great feather in the cap. One of the points here is that it can be orchestrated with Prism Central. And that's also a huge advantage because we're going to use Calm, we're going to use automation during those DR events, hopefully. To orchestrate things, so you can create a playbook that also gives you that ability to increase capacity. So it's just another avenue to meet your need. The net outcome, though, from a financial standpoint, is important too. You mentioned it, but I don't want to make sure that it doesn't get explicitly called out again. I see Harvey shaking his head. Do you want to take this one? I mean, I think it's a huge point to point out.
Yeah, I'll break it down to be very simple. More storage costs less than more nodes to get storage.
Yeah, and
but
especially
pay attention to performance.
Well, especially when we see these DR scenarios on AWS, a lot of times the licensing that goes along with it, plus the node itself, it becomes a cost prohibitive kind of thing. Now, with a 3-node cluster, you've got everything you need for a DR scenario. So it's really a great recipe for that elastic DR. And there's another graphic here in the blog post that shows the elastic DR, grow, basically multiple different ways. You've got your base, you add more storage from EBS until you max that out, and then you can add more nodes.
Man, this is scream. I know we're talking a lot about DR and the articles geared towards DR, but this is also screaming test, dev, staging. I mean, this opens up the door for development, getting development off site into cloud. I mean, this is going to be exciting for sure.
That also opens, for me, as I think about this, other types of workloads, maybe imaging and packs where they're very storage heavy that weren't necessarily compatible with the storage, the node types that we had inside of AWS. This may be a great way of doing some of that and tiering it down to a less expensive tier of storage, maybe not having to be all in NVMe.
We were riding the NUS bus last week. It sounds like we're getting back on it this week.
Yeah, I mean, there's so many good use cases. I know we're talking DR here because that really taps into the flexibility of this announcement, but there's other use cases for sure.
Absolutely.
I'm drawing a blank at this point. So Harvey, you want to save me here? What else is goodness that we should talk about?
This is, again, we talked about it a little bit. This is overall just another another play at flexibility, another play at being able to go out and attach more storage to what you have node wise. Again, just, you know how I am. I want flexibility always. I never want to be pinned into a corner. This allows you definitely a way to get out if you end up having to drag a bunch of data and don't have enough storage to do that with from how things were before. Now you've got the ability to just add that as you need it, which makes a huge difference.
Yeah, flexibility is the underscore. Just another way. I think you summed that up nicely, Jirah. You know, you've got so many ways to grow now. This is just another great enhancement. Final thoughts, guys?
It's a barrier remover to me, to be real honest with you. This has been a barrier that we've had with customers trying to get them to NC2. The second point I'll make, and we talked a little bit about this on the last podcast, is that this is where Nutanix really, this is our home, man, is data management. And so this is just another example of how, you know, we're looking at the zeros and ones, we're containing the zeros and ones, and we're managing the zeros and ones. And this is just adding to that story. So again, falls right into wheelhouse of what we're good at doing, which is managing data, the zeros and ones, and man, gives us more opportunity and flexibility in our cloud services. I can't wait to see something like this come to the Azure side. And man, I'm excited to see that happen in the next, whenever that's supposed to come. But this is good stuff, man. I'm very excited to see this come to market, and will make my job much easier when I'm communicating solutions to our customers in NC2.
Yeah. Yeah, nitro powered in this case. Jirah, anything else you'd want to add for our topic today?
I'd say if this is compelling, I'd say give it a try, give it a test drive, kick the tires. You can go from literally hearing my voice to having a cluster running in AWS in about 25, 26 minutes.
Yeah.
So faster than you really would expect. So you can prove this out to yourself pretty darn fast.
Yeah, that's a great point. And again, I mean, it's still powered by the same underpinnings. It still has all the same great advanced features on top of it. So it's that true portability, same services, same operational thing. We were having a customer discussion last week, and really came down to how do you operate, and operating the same way across multiple different destinations, multiple different clouds, not having to adapt for the individual sort of things in each cloud. There's a lot of power in that. A lot of power. Well, guys, I want to say thank you so much for joining us today to talk about EBS storage with NC2 clusters on AWS. This has been interesting. I was looking forward to today's conversation. So I want to thank you all for listening, and thank you guys for joining into the conversation.
Thank you, Phil.
Until next
Appreciate
time,
it, guys.
we will see you on the next podcast. Thanks, everyone.